Let us start today's session. We will be learning about pointers. Today, we will be learning about a topic called as a pointer. So, we will go with only very basics of it. How much is there in your syllabus? Okay. So, first of all, we need to understand the definition of a pointer. Okay. First, we need to understand the definition of pointers. Okay. Now, so the definition of pointer says that it is a variable, it is a variable which stores stores address of another variable, which stores address of another variable, which stores address of another variable. So this is called as a pointer. Now, if you look at the definition, okay, Okay, if you look at the definition, I am going to draw some image here. See, will it justify the definition of pointer or will it match the definition of pointer? Okay, okay. So, what is the meaning of variable? Variable means what? Variable means name given to memory. What is the meaning of variable? Variable is nothing but a name given to memory. Now, if you look at this image, so pointer is a variable. So pointer is a variable p. Variable means what? It's a name given to memory. It is a name given to memory. So p memory can store address. It can store address of another variable, right? Means p is a memory. It can store address of another memory. It can store address of another memory. So basically, can we say that P stores address and the above memory stores a value, and the above memory stores value. This is how you need to understand a pointer. This is how you need to understand a pointer. So basically, pointer is a variable which stores address of another variable. Now let us look at the syntax of declaring a pointer. So let us look at syntax of declaring a pointer. So what is the syntax here? The syntax is data type followed by star followed by pointer name or a variable name. Okay. Data type followed by star followed by pointer name. This is the example. Now, right? Sorry, this is the syntax. Now we'll go with the example. So let me declare a pointer to integer. This one we call it as pointer to integer. We call it as pointer to integer. So what is the meaning of this, right? So here pointer means it's a name given to a memory P. Okay. It can store address of another memory. It can store address of another memory, right? If P contains address of above memory, can I say that P is pointing to this? See, for example, let's say there is a guy called as, okay, there's a guy called as, right, Tim. Now, this guy has an address of a girl, right, whose name is Pooh. Okay. Now, if this guy is having her address, can I say that this guy is pointing to her? Means he knows her location. He knows her location, right? So this guy becomes a pointer, and this girl becomes a value, right? This guy becomes a pointer, and this girl becomes a value. Now, what type of value is this? This value is of type integer according to the declaration. So let me repeat it again. Okay, so p is a pointer. Okay, pointer means variable. Variable means name given to memory. So p is a pointer which contains an address of another memory. It contains address of another memory, and this another memory contains what there? It contains a value. It contains a value. What type of value? It depends upon your declaration. We call it as integer value according to this declaration. Are you able to understand? Let's continue, right? Let's continue and take one example here. Let's take an example here. Int star p. So assume that there is a lot of memory available here. There is a lot of memory is available. Okay, like this. You have lot of memory. Okay, like this. You have lot of memory. Now let us say that, right, whenever I declare a pointer, let's say this is the pointer p. This is the pointer p memory. Okay. Now this p contains an address of another memory, right, which is of integer value, right? So all are memories only. So p will contain address of this memory, right? So that is what I was trying to say. Now instead of drawing so much of memories, what I did was I took only two memories, right? One is p memory which contains address, and another memory which contains integer value. Why integer value? Because I've declared it as a pointer to integer. Okay, now, right, so this is the basic idea of pointer. This is the basic idea of a pointer. Okay, so I hope you guys are clear on this. We will discuss all that. Now let's start with one more example here. I have an integer variable int a is equal to 50. So there is a memory, right? There is a memory and whose name is a, and the value present in that is 50. Okay, right? That is 50. Now I will declare one pointer int star p semicolon. Okay, you declared a pointer. Now there is a memory called as p. Now right now it contains random address. We don't know where it is pointing. It is pointing to some memory. Okay, it is pointing to some random memory. We don't know where p is pointing. It is pointing to some random memory. Now I want to make sure that p should point to a. I want p to point to this variable or this memory. Now tell me, what does p should contain? If if we want p should point to a, what does the p memory should contain? So the p should contain address of what? Address of what? P should contain address, that is correct. Address of what it should contain? It should contain address of the variable a. Isn't that correct? So what should be present in p? P should contain, here we should store the address of a. We need to store the address of a. How do we get address of a? There is an operator called as AND. If you write this, this is called as address operator. Address operator. Okay, address operator. What is the job of this? It fetches address of variable. It fetches address of variable. Now once I get, when you execute this, this will fetch the address of the memory A. Let us assume, the address as, let us assume address as 1000. Let us assume address as 1000. So I'll write down here assumed address, assumed address. Okay. Now let us assume 1000 as a address of memory A. If I write ampersand A, what do we get? We will get it as 1000. Where we have to store it? We have to store it inside P. So what we will write? P is equal to ampersand A. When you do this, this thousand will be stored in P, and now P will point to this memory. Are you understanding now? So let us print the value of A. Let us print value of A, print F, double quote, percentage D, double quote A. So this will print 50. This will print 50. Now I want to print the value of A, but using P. Using P. Using P. So how will I do that? Print F, double quote, percentage D, double quote, star P, right? Star P. So if you write P, see, for example, if you write P, you will get 1000. Okay, you will get 1000. When you apply star on P, compiler will go to a memory whose address is 1000, and you will get what is present inside that. You will get what is present inside that. In simple terms, I'll show you here. Okay, let's say, right, this is Tim. Okay, and there is a girl called as, okay, Pooh, right? Now this guy has an address of Pooh. Address of this girl is 1000. So that address is present here. Now he is pointing to Pooh. Okay. Now if you say Tim, what will you get? What he is having, you will get that 1000. If you apply star on Tim, right? Now the control will go to Pooh, or control will go to this address, and it will give you Pooh. Are you understanding? Are you understanding? Again, I'll repeat this again. Okay, I'll just redo it again. Okay, see, first of all, understand ampersand means address operator. Address operator. Okay, address operator, right? And star is called as dereference. Dereference operator. Okay. Now, so there is a variable here, int b is equal to 100, or let's take 250. Okay, there is a variable called as b, it contains 250. So now, right, if I write ampersand b, right, I will get address of this b memory. So address of b memory, we don't know what it is. You can just assume some number. Let's assume it as 2000, or you can assume it as 5000. Some number you have to assume as a address, right? So now what I will do is I'll declare one pointer int star p. So when I declare a pointer, what will happen here? There is a memory p. It is pointing to some random memory. If I want to access this memory using p, right, if I want to access this b memory using p, now don't you think p should contain address of b? P should contain address of p. So how do I get address of b? I have to write ampersand b, right? I have to write ampersand B. This will give me address of B, which is 5000. Where I have to store it? I have to store it in P. Now I can say that P contains 5000. Okay, P contains 5000. Now P is pointing to B. P is pointing to B. So if you want to print B value, right? If you want to print B value using P, how we can do that? Right? How we can do is print F double quote percentage D double quote, right? P. If you write P, you will get what is inside that. If you write only P, you will get what is present inside P. So P means what here? What is the meaning of P? P means 5000. P means 5000. If you apply star on P, if you apply star on P, means you are applying star on 5000. When you apply star on 5000, control will go to a memory whose address is 5000 and you will get what is present inside that memory. Now, see here, the concept of applying star, the concept of applying star is known as dereferencing. The concept of applying star on address is called as dereferencing. Means, right? If you store address of B into P, it is called as referencing. If you apply star, then you will go back and get the value present in that address. So that is called as dereferencing. That is called as dereferencing. Is everybody clear? Now we need to understand the data type of addresses. Address. Okay. These are always present in, always present in or represented in hexadecimal number system. Hexadecimal number system. These are always represented in address. The type of the addresses is always hexadecimal. If you take any memory, right? If you take any memory here, A, okay. If you take any memory A, this the address of these are present like this FFE0, right? Or BFE0 or BCE0 or BCD0 or D2, like that. So these are called as hexadecimal numbers. Always the addresses are present in hexadecimal number system. Are you clear on that? I took, instead of hexadecimal, I took 5000 or 1000 or 2000 because it becomes easy for our mind to understand. Because our mind is not so much flexible with, or we are not so much familiar with hexadecimal numbers. So I considered a number, a hexadecimal number, which looks like integer, normal number. Okay, that is why I have considered 5000 there. Okay, now this is one part. Okay, next thing is we need to understand types of pointers. We need to understand types of pointers. So there are many types of pointers we have in C language. Let us start with the first one, right? First one is null pointer. Okay, the first one is null pointer. So what is a pointer, right? What is a null pointer? It is a pointer. It is a pointer that doesn't point to point to any valid memory, right? That doesn't point to any valid memory. So this is called as, right, null pointer. Okay, so it is represented by NULL. NULL. All must be in capital. It is represented by null. So for example, right, int star p is equal to 0, right? This will act as a null pointer. This will act as a null pointer. Okay, generally we don't write like this 0, we will write it as NULL. Okay, generally we write it as null. So p is a pointer which contains NULL, means it is not pointing to any memory. Null is not a valid memory, it is 0. So we don't have any memory whose address is 0. That is why it is called as null pointer. Okay, it is called as null pointer. Okay, now I will go ahead with another type of pointer. Okay, void pointer. Okay, it is a pointer, right? It is a pointer which can store which can store address of any data type. Address of, right, any data type. Okay, address of any data type. Okay, it can store address of any data type. For example, right, let's say I have an integer variable int a is equal to 50, right? Now generally where do we store address of integer variable? Generally, right, we store the address of integer variable in integer pointer only, correct? This is a general method of storing the address of an integer variable. So the address of integer variable is always stored in integer pointer. This is a general, right, method. This is a tradition what we follow. Okay, but if you want, you can store, right, int a is equal to 50, float x is equal to 2.5, and void star p1 comma star p2. I have declared two pointers. Now p1 is equal to ampersand a, p2 is equal to ampersand x. So see, look here, a is this a is a integer data type. I am storing integer data type into a void pointer, right? Into a void pointer. So basically, this void pointer can store, right? I'll just give you declaration. Declaration. How do we do that? Is void star vp pointer name. Okay. So this can store a address of any data type. Are you clear on that? Now see here. Some people look at, right, this scenario. Int star p or int star p, both are same. Both are same. It's just the place where you're putting a star. Both are same. No need of getting confused with that. Okay. Now we will go with another type of pointer. Okay. Array pointer. Array pointer. Okay. It is a pointer. It is a pointer. It is a pointer which points to first element of array. First element of array. Okay. For example, let us take an example here. Okay. I will declare one integer array int arr of is equal to 10, 20, 30, 40. Okay. So there is a sequential memory. Okay. There is a sequential memory like this. So let's store the values 10, 20, 30, and 40. Okay. Now let us assume address for these 1000, 1000, 4006. These are addresses. Red color ones are addresses. Sir, why it is 1000 and another one is 1002? There is a difference of 2. Why? Because, right, to store one value of integer, one value of integer, it requires 2 bytes, because the size of integer is 2 bytes, correct? So in 16-bit compiler, if it is of 32-bit compiler, then it would have been 1000, 1008, like that, right? So that is how the addressing happens. Now I will declare one pointer int star p is equal to arr. So what is this arr? Arr, if you write only name of array, it will give us base address. It will give us base address. So what is happening here? There is a pointer here, p, right? So what is the base address? Base address means address of first element. So that 1000 is stored inside this memory. Now I can say that p points to the first element. And if you want to print the first element, printf double quote percentage d double quote star p will give you output as 10. Will give you output as 10. Are you understanding? Next type of pointer. Okay. Dangling pointer. Dangling pointer. Okay. Okay. It is a pointer. A pointer that points to a memory location, a memory location that has been deallocated. Deallocated. See, whenever you declare a variable, what will happen? For example, if I declare a variable like this, what happens? A memory gets allocated, correct? Memory will be created. Now there is a pointer here, int star p is equal to ampersand a. If I do that, there is a pointer p, it points to this memory. But if I destroy this variable, if I destroy this memory, now p is pointing where? It is, we don't know where it is pointing, right? If you destroy this memory, then we can call p as a dangling pointer. Then p is called as dangling pointer. right? See, you will have some data inside that. If that memory only goes off, then such pointers will become dangling pointer. Okay, for I'll just write down here. Okay, so int a is equal to 50. Okay, so there is a memory a which contains 50, and there is a pointer int star p is equal to ampersand a. So there is a pointer p pointing to a. So this contains address of that. Now you destroy this variable. Now if a is destroyed, if a is a memory is destroyed, if a memory is deallocated, if it is deallocated, then p becomes dangling pointer. Okay, so these are the basics of pointers and uh, what do you call, the types of pointers that everybody must know. Very much basics of pointers. So if you have any doubts, you can ask. Thank you for watching.